Students, let us continue our discussion on the carbohydrates. Okay, in the last session we have discussed about the Roof's degradation. Today in this session we'll be discussing about the epimers and the epimerization process. So let us see what is first epimers and then epimerization. So epimers are the stereoisomers. You can call them as diastereomers, which differ in configuration at one of the asymmetric carbon. Okay, they differ in configuration at one asymmetric carbon. We call them as epimers. For example, let's take an example of glucose. 5, 6. Glucose has an aldehyde group. The third carbon OH is on the left side, and the remaining carbon OH are all on the right side. This is the structure of glucose. Okay, now this has 4 asymmetric carbon. What is an asymmetric carbon? Carbon attached to 4 different groups is called as asymmetric carbon. So it has 4 asymmetric carbon. So with the same formula, there are total 16 isomers possible, because the number of isomers possible is given by the formula 2 raised to n, where n is the number of asymmetric carbon. Since it has 4 asymmetric carbon, so there will be total number of 16 isomers possible with the same formula. So glucose is one of the isomer. So we come across another isomer that is called as mannose. 2, 3, 4, 5, 6. Mannose, the second and third OH are on the left side, and the remaining OH on the right side. So this is mannose. Okay. So difference between glucose and mannose is, look at this. This is the first carbon, this is the second carbon. Second carbon, this is the third, fourth, fifth and sixth carbon. So this is the first carbon. Now, if you look at glucose and mannose, third carbon OH left side, right side, right side, right side, right side. The only difference is this carbon. See here. In glucose, in the second carbon, the OH is on the right side. Here the OH is on the left side. That means they differ in configuration at this carbon only, this second carbon. So two isomers, diastereomers, which differ in configuration at one of the asymmetric carbon are called as epimers. So these two are epimers. They are epimers because they differ in configuration at this carbon. Since they differ in configuration at second carbon, so these are called as C2 epimers. C2 epimers. Similarly, galactose, glucose and galactose. Galactose is another isomer. So glucose and galactose are C4 epimers. We come across a molecule called as galactose. So glucose and galactose are C4 epimers. That means they differ in configuration at fourth carbon atom. 1, 2, 3, fourth carbon atom. In glucose, the OH is on the right side, whereas in galactose, the OH will be on the left side. Okay, there's the difference. So similarly, so glucose and mannose are C2 epimers, glucose and galactose will be C4 epimers. Right? So these are epimers. Now let us see epimerization process. Okay, how to change the configuration at one of the asymmetric carbon atom. Let us see that. Okay, that is we call it as an epimerization process. So epimerization involves the conversion of one epimer into another. That is conversion of glucose into mannose. So you are converting glucose into mannose. So we are converting one epimer to another. So we call that process as epimerization process. Okay, let us start with glucose. We have this 6 carbon atom, this is glucose. D-glucose. Okay. Oxidation. Okay. Glucose is subjected to oxidation by using bromine water. So bromine water, what it does is it converts this aldehyde into acid. So glucose gets converted into acid. 6 as usual. Okay. It gives you gluconic acid. This gluconic acid is heated in presence of pyridine. This gluconic acid is heated in presence of pyridine. Becoming important. Gluconic acid is heated in presence of pyridine. Okay. It gives an equilibrium mixture of gluconic acid, D-gluconic acid, as well as D-manic acid. So you get an equilibrium mixture of this 3, 4, 5, 6 acid. What happens is there will be change in configuration at this carbon when it is heated in presence of. So you get an equilibrium mixture, D-manic acid, D-manonic acid, sorry, D-manonic acid. Okay, so glucose is subjected to oxidation. You get an gluconic acid. When it is heated in presence of pyridine, you get an equilibrium mixture of these two, right? Now, then what is done is this, you are getting an equilibrium mixture. Then when this is heated, okay, in presence of, acid hydrolysis is what you carry out. So what happens is this gluconic acid gets converted into lactone, manonic acid gets converted into lactone, gluconolactone as well as mannanolactone is what it takes place. Okay, what happens is the fourth carbon, 1, 2, 3, fourth, this OH attacks here. Okay, so what you get is here, we have 1, 2, 3, 4, 5, 6 carbon atom. Okay, now this fourth carbon atom, it attacks here, you get a lactone. The remaining, it will remain as it is, OH, H, HOH. This is what you get a lactone. This is called as gluconolactone. Okay, this will give you mannanolactone. 1, 2, 3, 4, 5, 6 carbon atom. Fourth carbon attacks here, double bond O. Remaining as it is, OH, OH, H. So this is D mannanolactone. This is what you get. Okay, so these two can be separated by crystallization. So these two are separated. So these two can be separated by fractional crystallization. Then what is done is, once they are separated, only you can take mannanolactone and you can, on reduction, it will give you mannose. You can take a mannanolactone and you can convert it. Okay, what you should do is take manual. You can separate this. You get a mixture of these two. Separate these two. Take manual lactone and subject it to reduction. So when you reduce it, what happens is this lactone bond breaks and you get an aldehyde here. So you get this carbon 1, 2, 6 carbon. You get an aldehyde. The remaining as it is OH, OH, OH. You get mannose. Mannose is what you get. Simple method, students. Glucose is taken on oxidation, it will give acid. When it is heated with Brayton, it will give an equilibrium mixture of these two. This is then heated, you get lactones. So these lactones can be separated by fractional crystallization. So take this mannose and reduce it, you will get a mannose. Similarly, what you can do is you can convert D-mannose into D-glucose also, the same method. So this process is referred as an epimerization process. This method is referred as an epimerization. Okay. Now, another concept we need to deal is interconversion of glucose and fructose. Interconversion of glucose and fructose. Right. Conversion of glucose into fructose involves the following steps. Okay. In first step, glucose is treated with phenylhydrazine to form glucosazone. Then that glucosazone is hydrolyzed, okay, to give you glucosone. Okay, then reduction of that ozone, I mean also glucosone will give you a fructose. Okay, let us see how it actually works. Let us take first glucose. CHO 2, 3, 4, 5, 6. CH2H, third carbon OH on the left side, the remaining OH on the right side. So this is glucose. It is treated with excess of phenylhydrazine. You know what is phenylhydrazine? C6H5 NH2. And you know that when it is treated with excess of phenylhydrazine, what happens? You form a glucosazone is formed. That means 3 molecules of this will be utilized totally. So you get 2 C double bond N groups here. These two, right? So you get this compound 1, 2, 3, 4, 5, 6. So you get C double bond N NH C6H5. In earlier class we have done this, how glucosazone is formed. C double bond N NH C6H5, which okay, now you get glucosazone. This is an osazone of glucose, right? Now next, it is hydrolyzed. It is hydrolyzed, acid hydrolysis. So acid hydrolysis of this glucosazone will go give you glucosone. So what happens is this becomes C double bond O, this becomes C double bond O H. Hydrolysis takes place, this bond breaks, right? So you get this compound 1, 2, 3, 4, 5, 6 carbon atom, double bond OH, double bond O H, This is what happens. Then it is reduced. It is subjected to reduction using zinc and acetic acid. So reduction takes place. Aldehyde gets converted into an alcohol. So what happens is here 1, 2, 3, 4, 5, 6 carbon atom, CH2H. Sorry, should not have an hydrogen. Sorry. Okay, ketone, H, OH, OHH, OHH. Okay, make a correction here. It will not have an hydrogen. So this is what you get. So what you get is you get a fructose. This is glucosone. So this is how you can convert glucose into fructose. Similarly, fructose also can be converted into glucose. So initially fructose is reduced. Okay, it will give you an alcohol. Okay, so initially double bond O gets converted into OH in the case of fructose. Now the ketonic group will have asymmetric carbon atoms, so you will get two isomeric alcohols. One is D-sorbitol, okay, and D-mannitol is what you get. Okay, then it is oxidized, you get acid. Then on hydrolysis it will give you lactone. So then lactones, two lactones which can be separated, and then on reduction you will get glucose is what you get. So this is how fructose also can be converted into glucose. So this is about the interconversion of glucose and fructose. Okay, thank you.